One of the more tedious calculations in surveying when dealing with traverses is converting bearings to azimuths. These are just measures of angles, just like decimals or radians. Azimuth angles are measured from the northern line, and they're measured clockwise, and they range from 0 to 360 degrees. They're listed in decimal degrees. And bearings are actually given from a north or south line, and they can go either east or west. And bearings are defined using the north or south heading as well as the east-west heading. So there are 4 quadrants, and the angles range from 0 to 90 degrees, and they're also given in degrees, minutes, and seconds. So you have to do a conversion first from degrees, minutes, seconds to decimal degrees, and then you have to use some basic logic to get from your particular quadrant with a bearing and then reporting the azimuth. So the actual conversions are quite simple once you've got your angle in decimal degrees. So if the bearing is given, the decimal degree angle of the bearing is given as the angle symbol here. When you're in the northeast quadrant, they are identical, the azimuth and the bearing angle. When you're in the southeast, it's actually 180 degrees minus your bearing to get to your azimuth, which is the red line here. In the southwest, it's 180 plus your bearing angle, and then in the northwest, it's 360 degrees minus your bearing angle. So this takes a bit of time to do by hand, and it would be very easy to expedite these calculations using a spreadsheet and some of our basic text manipulation functions. So let's say we have an angle, a bearing angle that is north 45 degrees, 15 minutes, 16.7 seconds east. I'm going to copy this as well, and I'm going to intentionally add a couple spaces at the beginning and the end just to show you what happens and how we can deal with that. So you might think the north-south is fairly easy. We could use the left function, so equals left. And for the left, we need a text and a number of characters. So I'm going to grab the left first character from my bearing string. So that works here, but when I go to the case where they might be spaces that are hard to decipher, it doesn't work. So one of the things we want to do here first is use the trim command. Another thing we want to do is to eliminate any need to look for lowercase n's or e's or lowercase d's. So we're just going to capitalize the entire text string. So we can do that using the upper formula. So we'll point it to the text string, and now you can see that regardless of how we typed in the formula, we're going to be looking for capital N's, D's, and E's, or W's, or S's. The next thing we can do is use trim to actually remove any leading or trailing blanks, and this is eventually going to be the text string that we're then working with. So you can see I have the same formula at this point for these two angles, even though they're in slightly different formats. This one had a couple spaces and a lowercase n, and now they're both at the same point. So moving forward, this is the actual column that we're going to be using in all of our calculations. So I'm going to modify my north-south equation to be the left of this formula here, and I only want one character. And now you can see it works for both of those. For the east-west, since we did the trim operation, we can just use right, which returns a certain number of characters from the right of the text string or the end of the text string. And then what we need to do is now extract the degrees, minutes, and seconds. So the answer we're looking for is 45 degrees, 15 minutes, 16.7 seconds. So I'm going to copy these down to the second line just so we know that's what we're trying to achieve here. We don't want to have to punch these in manually for every single angle. That would just be tedious. So we want to find a way to deal with the particulars of our text string. So if we copy paste this as a value and we increase the size of this so we can take a look at our formula here, we've got a text string that either has a north or south in the first character, followed by degrees, and then a D to indicate the end of the degrees. Then we have our minutes, followed by the apostrophe to indicate the end of the minutes, and then our seconds that is followed by a quotation symbol, and then lastly our east or west heading. So in this text string, if we could identify the locations of certain characters like the D, the apostrophe, and the quotation mark, we can then take advantage of the mid function to pull out information from the middle of the text string. So I'm going to use the find function, so find, and I'm going to look for capital D within my text string. Now we can apply a third argument here, which is just the starting position, but it's optional. So I'll show you that if you leave it off, it's going to start at the beginning. For the location of the apostrophe, we want to find the apostrophe, so put that in quotations. So this is quotation, apostrophe, quotation, and we want to look in our same text string, and here I'll use the third character, or third option, which is just the starting point. And then lastly, we're going to look for the quotation symbol. Now the quotation symbol is a bit odd because you're using the quotation symbol to indicate a text string. So rather than have to enter in the quotation symbol as such, so quotation, 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 4 of them in a row actually gives you the quotation symbol, but that can be a bit confusing. So instead, I'm just going to reference a cell that has the quotation symbol, and I'm going to lock it so that it's always going to refer to that quotation symbol, and it does the same thing here. So with this information, we know that D is located at the 4th character, 1, 2, 3, 4. The apostrophe's at 7, so 5, 6, 7, and then the parentheses are at 12, so 8, 9, 10, 11, 12. And with that information, we can use some combinations of mid and that information to retrieve our desired values here. So for the degrees, we're going to use the mid equation, and we're going to be using the mid equation on this same text string. The second argument is the starting position, so we know that it always starts for the degrees in the second character because the first character has to be a north or south indicator. And then the number of characters is indicated by the position of the D, which is 4. And then from our example here, we know we have 2 characters, so we need to subtract 2 from that. And the -2 is really just getting rid of the north, south, and the D. And you can see our degrees matches up. For the minutes, we're going to use mid as well with that same text string. The starting position is actually going to be the location of the D plus 1, so 4 plus 1, and I'm using the cell reference there. And then the number of characters comes from the location of the apostrophe minus the location of the D. So if I were to do that, I have 7 minus 4, which is 3, and I need to get rid of 1 more character there. And then lastly, for the seconds, we're going to use mid of the same text string. The starting position is the location of the apostrophe plus 1, and then the number of characters is the location of the quotation minus the location of the apostrophe. So 12 minus 7 gives me 5, and I know that I have 1, 2, 3, 4 characters in this example, so I'm at 5. To get to 4, I need to subtract 1. And so these formulas allow me to extract the degrees, the minutes, and the seconds. To get the decimal degrees, we just convert, so we have degrees plus minutes divided by 60, because there's 60 minutes in a degree, and then seconds divided by 3600. There's 60 seconds in a minute and 60 minutes in a degree. So once we have that information, what we are left to do here is I'm going to use a format painter and just redo that format so it's not excessively large. What we need to do is use some logic to figure out our azimuths. So here is the logic that we need to implement, and what we need to decipher is whether we're in the north quadrant or north or south hemisphere, and then east or west section here. So to do this, we need to make a decision, and in Excel we can make decisions with the if statement. So I'm going to hide some of these columns to give us a little bit more room. So we don't need these 2 columns for now. So I'm going to use the hide formula, or the hide operation. These are all just supplementary calculations, so I'm going to hide those. And so now the information that we really need to make this calculation is the north-south heading, the east-west heading, and the decimal degrees. So for my formula here, it's going to be if. We're going to check to see if the north-south is equal to n in parentheses there. And just for temporarily, I'm going to put in the true spot the text north, and then for the false spot for it, false. Alright, this might be better represented as south. So if my information changes here, this formula is able to tell whether I'm in the north or the south. So once I know I'm in the north, the next thing I want to check is to see whether I'm in the east or the west. And that's again another if statement. So if this cell is equal to E, I know I'm in the northeast. Otherwise, I'm in the northwest. And I need to put a parenthesis to end my if statement. So this is the whole second argument, which is the value of true for this logical test. So if it is in the north, I'm going to check to see if it's in the east. Then I know it would be the northeast, and then if it's false, I know I'm in the northwest. So now if we play around with our inputs here, we know it's in the northeast. If I change this to west, it's able to decipher that. So my if statement now has placeholders for the formula that I need to apply in these particular quadrants. I'm going to do the same thing for the south. So if it's in the south, I also want to check to see if I'm in the east or the west. And so now I'm able to decipher if I'm in the southwest, southeast, northeast, northwest. So here is the first test, which is whether you're north or south. So here it's if it's in the north. This is the argument if true. And then the argument if false for if in the north is right here. So I'm going to just replace these. So instead of NE, I'm just going to display decimal degrees. For northwest, it would be 360 minus decimal degrees. For southeast, it's 180 minus decimal degrees. And lastly, for southwest, it's 180 plus decimal degrees. So to make this work for all of my equations, I'm going to unhide my columns, and I am going to copy paste this data, these formulas, all the way down here. And you can see that the ones that don't have data in are currently hidden. So we'll hide these. And now we have a place for input and the resulting output here. So we can try a couple of these. So south 1 degree, 15 minutes, 56.6 seconds west. So we have southeast, northeast, southwest, and so we need a north. We'll go 32 degrees, 45 minutes, and 12.345 seconds west. So I have examples for all four quadrants here, and my formulas appear to be correct for all of these. So let's take a look one more time at our formula. We'll unhide some of these things. So again, here we have our azimuth calculation that is dependent on the north-south heading, the east-west heading, and decimal degrees. So this should hopefully be useful to you guys when you're doing your traverse calculations. I think each of these calculations probably takes about 2 minutes a piece. So, you know, if you had 13 of these, you'd be saving yourself about 25 minutes of your life. So, should be useful.